So as I said in the preceding video that this figure is not the same as figure A, because if you notice that here the base is a rectangle and the other one the base is a square. So I'll go back to just show you. So here, if I want to find the height relative to each triangle, it's the same. Here, the height relative to each triangle, it's not the same. So here I have two different triangles. So the area of the base, it's 4 times 5, but I have 2 times area of the first two faces. So I have the face, for example, this one ABC and the opposite one here. Those are the same faces. I have the same height. Also, the height that I need to find it in the triangle, the right triangle, this one here. The first one here, it will be 2.5, and I have here the height is 6, so I will be able to find H1. So this is H1 here, and then I will find in this triangle, so H1 squared is equal to 2.5 squared plus 6 squared, so H1 is equal radical 2.5 squared plus 6 squared is going to be 6.5. And in this case, I can find the area of the face 1. It's base 4 times the height 6.5 over 2. Now, to find the height of the other face, so it's here. I will change the color, guys. So this is the base 5. I need this height here to be able to find. I will find in this yellow triangle here. So I have h2 is squared is equal to this one here. It's 2 squared because it's half of 4 plus 6 squared. So it's radical 2 squared plus 6 squared, so it's 6.3. So the area of the face will be also base times height over 2. And now I will be able to find the surface area of all the pyramid. This is the area of base, 4 times 5, plus 2 times the area of the first two faces, plus 2 times the area of the second two faces, and in the end I'm gonna have total area 77.5 centimeter squared. The volume is very easy. It's 1 over 3. It's area of the base. This is the area of the base times the height. Area of the base length times width times the height, and I will get the answer. Here the unit is wrong. It's gonna be cube. Sorry, guys. Now we move to C. Sorry, C is very easy. It's a cone. What is the area of the cone? Formula, it's pi r squared. So here it's pi 3 squared plus pi r, pi times 3 times s. What's s? This is s. This is the slant. Do we have the slant? We don't have it. I need to find it. Where I will find it? Pythagoras again. In this right triangle here, I can name it if I want A, O, B, for example. So I will have 9 squared plus 3 squared gives me the slant squared. So S is equal radical 9 squared, so 81 plus 3 squared, so it's 9. Then I will got the S is 3 radical 10. And now I just replace pi times 3 squared plus pi times 3 radical 10, and I will get the answer. For the volume formula, 1 over 3 pi r squared h is AO, it's 9 centimeters. So I replace and I will get the answer. Figure E, it's a sphere. Area, it's pi r squared, 4 pi r squared. I have the diameter 16.4, so the radius is going to be 16.4 over 2. I replace, I calculate. The volume is 4 over 3 pi r cubed. And also again, I will find the radius by dividing the diameter by 2. Let's move to exercise 2. It's easy. Exercise 2, it's a hemisphere, it's a half sphere as a diameter 5.6, and I need to find its volume. So volume of this hemisphere is half of the volume of the sphere. So it's 4 over 3 pi cubed over 2. So it's 4 pi 2.8 cubed because it's half of it over 6 because over 3 over 2 going to be over 6. I replace and I will get the answer. I will move to exercise 3. I need to find the volume of all this figure. This figure is formed by a cylinder plus a cone, and I just need to use the formula. It's volume of the cylinder pi r squared h, so it's pi times 3.2 squared times the height is 9.8 plus the volume of the cone. It's pi r 1 over 3 pi r squared. It's the same radius. It has the same radius, 3.2 squared times the height 6.2, and then you replace and you calculate. I'm going fast, guys, because it's very easy. Just you are using the formula. Exercise 4, we will read and explain it. A plant pot is made out of clay. So the pot has the shape of a hemisphere with total radius 9 centimeters. So you know that the pot is thick from here. And this, all my objective is to find the volume of this thickness here. Now, and a hollow hemisphere of 8 centimeters. So it's inside 8 centimeters. Now, assume no clay is wasted. So I don't want to waste any clay. Find the volume of clay required to make the plant pot. So how many, what is the volume of clay that I really need to find to be able to do this pot? You need to understand, as I'm saying here, that as I have a bowl, half a bowl, it's full. Okay, I'm emptying this, but I need to keep a small part from it, and the distance here from here to here is just 1 centimeter. So as I just need to find the volume of this one, the thickness here. So to be able to find the volume of this part here, I need to find the volume of all the hemisphere, all of it, and I'm emptying. I want to empty this inside to be able to put the flower inside. So when I empty, I'm trying to empty the inside, means I'm doing a minus. So it is the volume of the whole this hemisphere minus what I'm removing. I'm removing this inside, and I'm removing the hemisphere of radius 8, and this one will give me the volume of the clay that I need to be able to do it. So I repeat again, it's as I have a full hemisphere. Okay, that's it. The volume of this full hemisphere, I know it's 4 over 3 pi r cubed over 2, and the radius is 9. But now I want to empty it from inside to be able to put the plant. If I want to empty it, I'm removing part of it. I'm removing the part of the hemisphere that has a radius 8. So minus, what's gonna still remain? It's gonna still remain the clay that I really needed to be able to do the spot. And then so it's the volume of the big hemisphere, 4 over 3 pi r cubed over 2, and here r is 9, minus the volume of this small one of the radius 8. And this is what I need to be able to do this pot. Number 5, it's also very easy. I have 12 spheres, each with a radius of 3, are fully immersed in a cylinder. So this is a cylinder here, and inside the cylinder I can put how many spheres? 12. And the cylinder is full of water, but once I put all those 12, all the water is going out of the cylinder. The cylinder was full of water. Okay, so I know that the cylinder has a radius 10 centimeter. Find the rise in the water level. It means I need to find the height. So I know that when I will put all those balls inside the cylinder and I'm emptying the water, the volume of all those 12 spheres gonna be equal to the volume of the cylinder. And I'm gonna solve just an equation of an unknown. So the volume of the 12 spheres is 12 times 4 over 3 pi r cubed. It's not r squared. Okay, r1 cubed. It's equal to the volume of the cylinder. It's pi r squared h. What is the unknown? This is one is unknown. And I wrote here r1 because the first radius is 3, the second radius is 10. And then I just replace. So I will have h is what? It's 12 over 3, 4 times 4, 16 pi r cubed. Sorry guys, I don't know why it's written like this. Okay. 16 pi r cubed over pi r squared, and then I just replace. This radius is 3, this radius is 10. I replace and I will get the answer 4.32. So I repeat again, all the cylinder is full of water. When I will put all the spheres, the 12 spheres, I'm emptying all the water. It means the volume that I put inside the cylinder is equal to the volume of the water that it went out. So the volumes of the 12 spheres are equal to the volume of the cylinder. The volume of a sphere is 4 over 3 pi r cubed. So 12, it means 12 times. I wrote here r1 because this is the radius r1 and this is r2. And then I solve the equation. This is the unknown, so divide by pi r. This I put here r2 and r1, so you will know the difference. And then I just replace and I will get the answer. The last exercise is very easy. In this diagram, I have a large cone of height 45 centimeter and base 15 centimeter. It is constructed by placing a small cone A of height 15 centimeter and the base of diameter 5 centimeter on top of a frost tube. Find the volume of this. So I need to find the volume of this one. So it's very easy. I'm removing from all the cone the top. So what's still remaining? So it's the volume of the big cone minus the volume of the small cone will keep for me the remaining part. What's the volume of a cone? It's 1 over 3 pi r squared h. The diameter is 15, so the radius is 7.5. The height here of the big cone is 45. Now the small cone here, the top, it's pi, the radius is 2.5, the height is 15, and then when I subtract, I will get the volume of the remaining part that I need. That's it. Again and again, watch again the video, and you know that if you have any question, guys, you can ask me anytime you want.